So, like I said, today we are going to graph solutions to linear inequalities in two variables. The next task we have is that we want to refresh ourselves about how to solve and graph each of these inequalities in one dimension, essentially. So when I divide both sides here by 3, we get something similar to this. X is greater than -5. And if we recall how to graph this puppy, we need to put a -5 there, a -4 there, and a -6 there. Because of this symbol right here, we are going to use an open point. There's no line underneath, so we do not include. And I'm going larger, greater than, which means the number 0, which lives somewhere over here, should work. So when I plug a 0 in here, 3 times 0 is 0. Is 0 greater than -15? Ka-chow, ka-ding, it works. The only other thing you need to consider is we have to spend some time watching out when we multiply or divide by a negative. Beep, 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 beep. The moment you divide by the negative or multiply by a negative, you need to switch that symbol direction, immediate. And then our solution here, or solutions, is x is less than -5. And notice it's the same situation as the previous problem. -5 here, -4 there, and -6 here. We're also going to have an open point, but this time I'm going to shade less than. So all the real numbers that are less than -5. And it can include decimals and fractions, etc. Notice that 0 does not work. So if I plug a 0 here, I get 0. Is 0 greater than 15, the original problem? The answer is no. Good. I expect this to be false and this to be true. Please take a moment to work on this other one. And I apologize, this should say C. Under what conditions, when you're graphing on a number line, what symbols are an open point and make you shade right? In particular, let's think about our variable, like if we had our variable x. What symbol do I put there that says it's going to be an open point and a shade left? When's going to be a closed point and shade left? So what symbols go into there? The symbols, again, that I'll give you a hint as is less than, greater than or equal to, less than or equal to. Place those in and take a moment to check that with your neighbor. Go. So here's our review. Notice our variable does need to be on the left side. So less than means open point, shade to the left, excuse me. If it said x is greater than, then I'm going to be open point and shade to the right, etc. Now we're going to preview, because over here for review, we were talking about one dimension in 1D, which is just a single line. Today we're going to talk about 2 dimensions in 2 dimensions, x and a y. We also call that the coordinate plane. So we're going to be seeing how things work on the coordinate plane. All right, so very similar in ideas. But instead of using an open and a closed point like we did over here, just to show you don't need this, but open point here and a closed point there. Same idea, but if I'm graphing on a plane, I don't want to do open points all across like this because I'm trying to make a line. So instead of doing open points or closed points, we're going to have dashed line like so, or a solid line like so. So, the context is also important here. We do need to have the y is solved for these rules to work. It is possible to think about these rules without the y's by themselves, but for now we're just going to have it y by itself. So when do we have a dashed line and shade below? That's a less than symbol. When do we have a dashed line but shade above? That's a greater than symbol. So when do we have a solid line and shade below? That's a less than or equal to. And lastly, greater than or equal to will give me a shade above and a solid line. The only exception to this has to do with the vertical line. If we think about it, if I graphed a vertical line, there is no above and below that line, right? It's to the left, to the right, or to the left. So in that context, looks like this. If x is greater than, then, well, let me change that up just to keep it consistent. If x is less than or x is less than or equal to, we are going to shade to the left. In other words, we shade underneath like that, like to the left of the line. And the same thing here. If x is greater than or equal to, in this case, we shade greater than, which is to the right. So instead of thinking about above and below, you could also just think about it greater than or less than. Above usually means greater, and right means greater also. So now when we test this, 0 is less than 1. That's true. So the answer is yes. 0, 0 is a solution. Again, we have an infinite number of solutions that are going to be here. Infinite number of solutions, all in the shaded region. Because it's dashed, it does not include those. 0, 0 is among that, so I know it works. Conversely, if I didn't know which way to shade, and I check 0, 0 and it works, just go shade that direction. And we'll look at that in a little bit. I'm going to keep walking and do 1, 1 and negative 3, 4. You're welcome to jump ahead and ignore me and practice on your own. And just to check your work here, when you plug 1, 1 in, and if you were to look on the graph where 1, 1 lives, 1, 1 is right here. And so my expectation is that it's outside the region. And so we would say it's not a solution. But when I do check it, I see that's true because it's false. What? When you plug it in, you get a false. So therefore, it is not a solution. And my assumption about it being not a solution is true. Last one is we checked something that was on the line. Negative 3, 4 lives right here. And it's on the line. Shouldn't that work? And the answer no is no. Because look, 4 is less than 4. That's not true. I cannot be taller than myself. I cannot be shorter than myself. So in this case, that's false, so it's not a solution. Just so you can check your work here, the answer here is yes. The answer here is no. And what we get on the last one? Yes. Get a yes? Yes. Okay. And the answer, yes. So let's just double check. 8 minus 2 is less than 5? No, I misinterpreted, so got to watch out. Because the x and the y are switched around. So 1 goes there. So it's 1 minus 16 is less than 5. It's a yes. Had I was looking at it first and said, oh, look, I just put the x there and the y there. Wrong. All right. Next thing we're going to look at, and this will probably where we're going to conclude for the day, is we're going to teach you how to graph the solutions. How to graph the inequality. To get from here to down here. So here are our steps. First off, you're going to graph the line with an equal sign. But you're just going to pay attention whether it's dashed or solid. Next, you can test a point. And last, you can shade. By the way, B and C can be switched around. You could just shade it according to logic and then test the point as a check. So it doesn't actually matter which one comes first here. Some people have a preference, and I do not care. Whatever cranks your tractor, whatever floats your boat, whatever waxes your lip. So you could do ACB, or you can do ABC here. But A does have to come first. So let's take a gander at example number 2, part A. Because this one is slope-intercept form, I want to use slope and intercept. Over this one, B is standard form, so I'm going to use the x and the y intercepts there when we get to it. So, looking at this puppy here, M is 1/2. In other words, how I move is going to be up 1 and right 2, or down 1, left 2. But where I begin, that's my y-intercept, I begin at 4 on the y-axis. So let's just plug that in. 4 is right here. And then for slope, I'm going to go up 1 and right 2 to here. Puts that right there. And repeat that process, up 1, right 2. Or I could go down 1, left 2 down 1, left 2. Now I've got the line-ish, but before I connect the dots, which is so tempting, I need to assess what type of line I have. And because of this puppy right there, the equal to sign, I am going to use a solid line. According to my logic that I did here, too, this less than symbol should mean I'm going to shade below. So we've just dissected this entire inequality. I have the solid line, it's going to be a shade below. I have a slope, and I have a y-intercept. So let me go ahead and draw that solid line. So I can now just connect the dots. Like so. And we need to shade. So I did say shade below. And let me show you 2 ways that you can shade neatly. Okay? Please do not do this. Like this. It doesn't ever really look good. So I would encourage you not to do that. If you want to use lines and stuff, you could do something like this, where you just say, I'm shading, in this direction. So that kind of keeps things neat. The other option, of course, is to use the side of your pencil. And if you use the side of your pencil, and on the iPad it doesn't show as well, but if I use the side of the pencil, it's going to end up looking something like this. So then I would be a little bit more complete with that. It's a gentle shading, folks, not very, very dark. So don't shade, like I said, like that. It just makes it really hard to read behind. So a gentle shading. In fact, you don't have to shade every single component there, just to save on time. Whoops. And I'm going to shade the bottom half of the coordinate plane, like so. Again, please don't spend an hour making the shade look good. I appreciate that things look nice, but for the sake of time, just make it a kind of a quick shade, either like this or with the quick arrows. When we are shading like this, notice we dissected everything here, dashed line. I am going to shade above. Let's go ahead and do a test right now. And again, as a reminder, the test could come first, like here, and then you shade, or you could shade and then test. Here, the test is checking, is effectively a test. Try that again. Is effectively a check. So let me see if 0, 0 works. I expect 0, 0 to be true because it's right here among the shaded stuff. So y, try that again, 0 is greater than 2/3 times 0 minus 2. 0 is greater than -2. Super. I expected it to be true, and it was true. Now, remember, you don't have to graph all lines using slope-intercept form. Whatever really works for you. So in this case, I'm going to do, because I have standard form, it's so much easier just to find the x and the y intercepts, right? So the x-intercept looks like this. Remember, all you do is cover this up and then then solve the equation that's associated. So here, x is 6. So I can quickly graph that, x being 6. Sorry about that. I accidentally flipped that upside down. All right, so I changed the scale here. And I'm going to go ahead and graph that x is +6, which lives right there. Next, remember, if I just cover up the x, that'll help me find the y-intercept, like so. When I solve this, don't forget that when I should consider it an equal sign just for my purposes right here. I get a -4. So graphing the y as -4 is right there. And I do need to interpret right there. I have a dashed line. So when I connect these dots, I go dashed. So let me do that. Like so. Now, of course, the next question is, which direction do we shade? And I'll give you a hint. you cannot trust this symbol right there. It says greater, and you say, oh, I should shade above. Not quite. That's not always going to be true. Sometimes not. So in this case, I'm going to follow this, where I'm going to test the point and then shade. So 0, 0 is always a good one to test. So I'm going to test 0, 0 to see if it works. Does this point here work? So let's just plug things in. 2 times 0 minus 3 times 0. Is that greater than 12? And the answer is 0 greater than 12, which means don't shade up, because that's where 0, 0 is. So we have to shade down, like so. And you can check this answer here. Now, our next thing we're going to look at is how to write the equation from the graph. So essentially, we're going backwards. The nice thing about this is there's no real work to show. All our data is here. All we have to do is translate it into an inequality. So let's see here. The first thing I note is that I have a solid line. So I'm going to use a equal to component. I'm shading above, so my y is greater than. So I can actually just start there. Y is greater. Next, I need to know where I begin in terms of my y-intercept. So I begin here. Here's my -2. So my b is -2, which is going to go here. Next, I need to count to get to my one point to the next. So my slope is positive, and it goes up 1, right 1. Hence, thus, therefore, my slope is 1 over 1, which is equal to 1. And my final result is this. Y is greater than or equal to x minus 2. The same idea works over here. So I'll walk through the process on this one. Dashed line, so I do not need an equal. I'm shading above, so it is greater than. I'm starting at -1, so I go there. And I go up 2, right 1, so my slope is 2. So y is greater than 2x minus 1. And please do the 3 down below for practice. And we can check our work here. The penultimate thing we want to get through today is we want to do an application. Most of life is actually inequalities, because if you have $100 to spend on a part of your video games or whatever, you don't have to spend $100. You can spend underneath the $100. You don't have to spend exactly. So most of life is actually inequalities, not equations. We think of them as equations, and then we just adjust our thinking after that. So let's take a gander at a basketball game. You're listening to the basketball game on your car radio while driving, apparently. At halftime, Coleman has already scored 24 points, but you have to turn off the car and go to work. So let X represent the number of 2-point baskets scored. Let Y represent the number of 3-point baskets scored. What is the inequality that describes the possible number of 2-point and 3-point shots that Coleman could have scored by the end of the game? Determine 3 ordered pairs that are solutions of the inequality all the way up to where he scores 15 2-point baskets or makes 15 3-point baskets. All right. So what's nice here is that we're not doing a system, so we just have one equation to consider. So what we do looks like this. Remember that each 2-point is worth 2 points. So 2 times x will tell you how many points earned from free throws or 2-point baskets. Next, the other one is a 3y from the 3-point range. And that'll tell you how many points he shot from beyond the 3-point range. And lastly, the 24 is going to be here because he's already scored 24, so he can't go under that. So what symbol are we going to put right there? Good. Greater than or equal to. Now, he could score no more points henceforth. You turn off the car and walk away, and he could have scored nothing else. Maybe he injured himself or got pulled out or just had a bad night. All right, now what we're going to do is graph this and then look at a few possibilities on the graph for what he could have scored. Okay, because this is already in standard form, I'm going to cover things up and just find each intercept like so. So the x-intercept, in other words, if he only scores using a 2-point basket, then he did 12 of those. The other option is to erase that, that here, and then 3y is equal to 24. So had he only scored 3 points, 3-point baskets, shot them, then he would have made 8 of them thus far. So we need, on my axes here, we need to define what they are. So down here, I'll call the number of 2-point baskets, which means over here would be the number of 3-point baskets, x and y. So x is 12, so I'll put a little point there. And then y is 8, goes here. Notice we don't go in the negatives because you can't make a negative shot, at least for your team. You can technically make a negative shot interpretively if you shoot to the other basket and make it. But that doesn't count against you except socially. We're going to be shading above now into this region here. So he could have made any of these possibilities, almost. Although we're shading, which is what we've been teaching you to do, just to shade, and these are all solutions, what are some limitations of my shading? And I'll give you a hint. It has to do with the number of baskets. So the limitations on this one are technical. Really, all we're looking at are just these points right here. But it takes so long to have to plot all of those dots that we don't do that. Shorthand, we just shade everything because technically we can't include anything inside the boxes. And the other point, of course, is since the game ends, we're not going to technically score up into infinity. We'll max out at some point.